Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in yesterday's class, we discussed the chapter number system. Let us go for continuing that in today's class. Before going to that, just we shall recall some of the important points what we learned in yesterday's class. We learnt about different types of numbers. You may just recall them. First one is counting numbers called natural numbers. Second one, natural numbers including 0 are called whole numbers. Third one, whole numbers including their negatives are called integers. And fourth one, this is also very important, even I had told you to learn the definition of this, that is rational number. The definition of rational number is a number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is the definition, please do remember. And even we learned how to find out the number of rationals between two given rational numbers. Today let us go for continuing the problems, and before that one more small instruction. For in today's class we need to have some of the geometrical instruments. They are, you need to have the scale, then a set square, protractor and compasses. Okay, let us continue the class. In the last problem, in the previous problems we have learned how to find out number of rationals between two given rationals. Here, in another type of problem, they may ask you to find out just only one rational number between two given rationals. That too, it should be exactly the midpoint of the given two rational numbers. Let us come to know how to find it out. It is fifth one. Here I'll write. You can also copy with me. Find a rational between, I'll go for taking simple one, it is 11 and 12. Two consecutive numbers are there, a rational between these two rationals. Here, just I go for adding them. Now could you tell how many numbers are added? Two numbers. So let us divide it by 2. It is equal to 11 plus 12, it is 23. 23 by 2. So it is a rational number between 11 and 12. And just you can recall the last year concept what you had learned. Sum of terms divided by number of terms. What it is? Mean or average. Hence this method is known as mean method. What it is? Mean method or arithmetic mean method. So the question can be asked like this. Find a rational number between 11 and 12 by mean method. Here I'll write by mean method. Yes, you can copy this. Now, sixth one. Whenever I ask you to copy, you can do one thing, just pause the video, copy that completely, then continue, so that we can save our time. Now, sixth one, again I go for taking one more example for finding the rational numbers between two given rationals by mean method only. Go on writing with me. Find just a rational, one rational, a rational between 2 by 3 and 7 by 4 by mean method. By mean method. Now look at it. So I go for adding both the rational numbers, that is 2 by 3 plus 7 by 4. Divided it by 2 because there are two rationals. Now simplify numerator by taking their LCM. LCM will be 12. You know that addition of rational numbers. I go for telling you in a simple method. Here 3 and 4 are the numbers which are not at all divisible by any number except 1. Under such condition, LCM will be, see the 3 4s are 12. Then even simplification will also be very easy. Now 4 is there, 4 2s are 8 plus 3 7s are 21. So this method is applicable if and only if the denominator terms are primes. Denominator terms are co-primes. Yesterday only I told you what are co-primes. A pair of numbers having no common factors other than 1. Now whole divided by 2. This is equal to, what is 8 plus 21? It is 29 divided by 12. Whole divided by 2 is there. Take the reciprocal of this denominator. 2 by 1 is there. It becomes 1 by 2. We have converted the division into multiplication. It is equal to, now multiply numerator, 29 ones are 29, 12 twos are 24. So this is a rational between two given rational. Understood? Yes, you may go for copying. Here I write the conclusion. Therefore, a rational between 2 by 3 and 7 by 4 is 29 by 24. In the worked examples, we have solved 5 problems. In these 5 problems, total 6 problems are there. From all these 6 problems, we can conclude 2 important points. One is, could you first tell the answer? How many rationals are there between two given rationals? 1, 2, just 3 or 10, 15? No. Any number of rational numbers can be found out between two given rationals. Hence, we can conclude that there are infinitely many rationals between two given rational numbers. Let us write the conclusion. Right now, there are infinite number of rationals between two given rationals. Written up. Okay. Another point. Observe here. In the arithmetic mean method, just this will be used to find out the number which is exactly in between two given numbers. If A and B, don't copy, just observe. If A and B are there, if A and B are rational numbers, what is a rational number between these two? Can be written as A plus B by 2. Got it? You can copy this. If A and B are two rationals, then a rational between them is, you can copy this, A plus B by 2. Over. Now, both examples are over. We can go for focusing on the exercise problems. Here, now we have come to the first exercise number 1.1 from NCERT text. Right. Exercise 1.1. The very first one, copy with me. Is 0 a rational number? Is 0 a rational number? This is first sub question. Now another one is there. Right. Can you write it in the form P by Q? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Put question mark. There are two sub questions, both they start with the helping verb is and can. It is just a yes or no question. Is 0 a rational number? Yes, 0 is a rational number. That we have already come to know. Why 0 is to be considered as a rational number? Because 0 can be written in the form of P by Q. How? 0 is equal to 0 by 3, 0 by 1, 0 by 5, any number. So let us go for answering that. Right. Answer? Yes. 0 is a rational number. Zero is a rational number. Now, another sub question is there. What it is? Can it be written in the form of P by Q under the condition P and Q are integers and Q is not equal to 0? For that also we can write yes. Right. Second answer for second sub question. Yes. 0 can be written in the form P by Q as 0 by 1, 0 by 3, 0 by 11 and so on. Clear? Now, second. The second question is, find 6 rationals between 3 and 4. Let us write down. Find 6 rationals between 3 and 4. Let us go for finding the total 6 rational numbers between 3 and 4. That we have already learned in yesterday's class. Let us go for following the same method. How many are going to be found out? 6. Then you can go for adding 1 to it. So 6 plus 1 it is equal to 7. Next write 3. Then multiply 7 and divided by 7. It's equal to 3 7s are 21. 21 by 7. Next 4 is there. 4 is equal to 4 into again 7 by 7. It's equal to 4 7s are 28. Then whole divided by 7. Denominator terms are same. Hence you can go for writing number of rationals. Here 21 by 7. 22 by 7 and so on. Last one is 28 by 7. What is 21 by 7? It is 3. 28 by 7, this is 4. Then we want 6 rationals between these two numbers. Let us write that. Therefore, the 6 rationals between 3 and 4 are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and another one is 27 by 7. You can go for copying this. As I told you, again and again I have been reminding you to copy that. Just you can go for pausing the video. Then after copying is over, then you can come back to the class. Now, I'll go for next question. The next question is, it is find 5 rationals between 3 by 5 and 4 by 5. So this problem was already solved in yesterday's class. Hence, I go for writing it as solved. Now, let's move on to fourth one. Copy with me. Here they are given true or false questions, and we have to give reasons as well. Right. State whether the following statements are true or false. State whether the following statements are true or false. Full stop. Give reasons for your answers. Give reasons for your answers. Yes. Let us go for taking the statements one by one. The very first statement is every natural number is a whole number. First copy this. Every natural number is a whole number. You just go through the given statement. Do you say that it is correct? Every natural number is a whole number. If I go for writing the whole numbers, they are 0, 1, 2, 3, 4 and so on. All these 1, 2, 3, 4, they are all natural numbers. Hence, we can say that all natural numbers are whole numbers. Right answer. It is true. What is the reason for this? Reason is whole number contains all natural numbers. Right. Whole number contains all natural numbers. Written up. Next, go for second one. The second one is every integer is a whole number. Copy this. Every integer is a whole number. Every integer is a whole number. Let us go for answering this. Then, just as we have already learnt about integers, I go for taking some of the examples. Here, observe them 0, 1, 2, 3, 4 and so on, and -1, -2, -3 and so on. Every integer is a whole number. See that 0 is an integer, is also a whole number. Even similarly 1, 2, 3, 4 and so on. What do you say about -1, -2, -3? Do you say that -1 is a whole number? No. Got it? So that is why the given statement is false. Right. The reason is whole numbers do not contain negative numbers. Right. False. Because whole numbers do not have negative numbers. Whole numbers do not have negative numbers or negative integers. Now, let us go for third one. Third one is right. Every rational number is a whole number. Every rational number is a whole number. What do you say about this? Every rational number is a whole number. I'll go for writing the rational numbers. 0, 1, 2, 3, 2 by 3, 7 by 4, minus 2 by 3 and so on. See that? These are all these are rational numbers. 0, 1, 2 and 3, they are all whole numbers. But what do you say about 2 by 3? Is it a whole number? No. Now we can say that it is false, right? It is false. What is the reason? Because whole numbers are not in the form of p by q, like 2 by 3, 7 by 4 and so on. Because whole numbers are not in p by q form, like 2 by 3, 7 by 4 and so on. Done. Now let's move on to the next part of this chapter. In the next part of this chapter, we are going to learn another type of number, that is a number which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0. What do you call such numbers? They are called irrational numbers. Please write the definition with me. Side heading: irrational numbers. Once I tell the definition, listen carefully. The numbers which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0. For example, root 2. Root 2, it can be written in the form of p by q as root 2 by 1. But do you say that root 2 is an integer? We know that condition p and q should be integers to say it is a rational number. But here root 2 is not an integer, hence it is irrational number. So write down the definition with me. The numbers which cannot be expressed in the form of p by q, which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0, are called irrational numbers, or just you can write irrationals. Irrational numbers. And the collection of irrational numbers is denoted by the symbol, it is q dash. Then example for this, you can write the root numbers: root 2, root 3. Can we write root 4 as irrational? You cannot. Why? We know that the value of root 4 is 2. 2 is a rational number. Hence it is not an example. Root 2, root 3, root 5, root 6, root 7, root 8 can be written, root 10 and so on. These are some of the examples for irrational numbers. And we have some information about irrational numbers. Let me go for giving you them. Listen carefully. Do you know the first persons who thought about the numbers which are not rationals? They are Pythagoreans. They are Pythagoreans. Pythagoreans means they are the followers of Pythagoras. The Pythagoreans are the first who thought about the number which are not in the form of P by Q. And there is a myth that one of the Pythagorean, that is follower of Pythagoras, is Hipparchus of Croton place, and he had an unfortunate hand for disclosing or the discovering root 2 is irrational, and root 2 is irrational was discovered by Pythagoreans. Similarly, we have some more information that that one of the symbol, that is pi. Pi is also an irrational number. It was proved by two great mathematicians. One is Lambert and another one is Legendre. You all may be thinking that, sir, many times we have used pi is equal to 22 by 7. It is just an approximate value, but it doesn't have exact value. Pi is an irrational number. These are some of the information regarding irrationals. Please copy them. They are also very important in the examination point of view. Right. Some important points. Others note, you can write note with respect to Q dash. Notes with respect to Q dash. First one, go for writing them. Pythagoras and Pythagoreans were the first who discovered number which is not irrational. And the first irrational number was discovered by again Pythagoreans. Which is that first irrational number? It is root 2. Root 2 was discovered by Pythagoreans. And third important point, it is, as I told, one of the Pythagorean who had an unfortunate end, who is Hipparchus. One of the Pythagorean, that is Hipparchus of Croton, had an unfortunate end for disclosing root 2 is irrational. So this information was root 2 is an irrational number. It was disclosed by Hipparchus to the people. So that is why he had an unfortunate end. That was the information was given in myth. And one more information, as I told you, pi is an irrational number. Who discovered them? Who discovered it? They are, one is Lambert and second one is Legendre. Right. Pi is an irrational number was proved by Lambert, L-A-M-B-E-R-T, and Legendre, L-E-G-E-N-D-R-E. And another information, other than root 2, some more numbers are there, like root 3, root 5, root 6, root 7, root 10, root 11, root 12, root 13, root 14. All these are irrational numbers, and these were proved by another mathematician. He is Theodorus. Theodorus of a place called Cyrene. Right. Theodorus of Cyrene, Cyrene, Theodorus of Cyrene. Theodorus of Cyrene, he has shown that root 3, root 5, root 6, root 7, root 10, root 11, root 12, root 13, root 14, root 15 and root 17 are irrationals. Yes. I hope that you all have copied. If not, again, I'll give you the instruction that pause the video, then copy all these points, then you come back to the further part of the chapter. Let us move on to it. Now, let us go for taking some of the rational numbers, and even we know that how to represent them on the number line, which you have already learnt in your previous classes, right? Even from 6th standard, 6th, 7th, in all these classes you have learnt how to represent rational numbers on the number line. Now, in today's class, we are going to learn how to represent irrational numbers on the number line. Do you know the mathematicians who had given the concept of number line? Yes, there are two mathematicians. One is Richard Dedekind and another one is G. Cantor. Right now, let's move on to the concept called number line. Number line. Who has introduced this? The number line was introduced by, it was introduced by Richard Dedekind, or Dedekind, D-E-D-E-K-I-N-D, and another mathematician, G. Cantor. Let me go for drawing the number line. Please go for taking a scale and draw a line. So this is the method of drawing the line. Don't draw like this. Now, go for marking the points. It is 0 and this is 1, 2, 3. Here, -1, -2, -3. And one more thing you must remember, and it is also an important point. Corresponding to any number, there will be a point on the number line. Suppose you go for taking 1/2, and that with respect to 1/2, there is a point on the number line here. Similarly, corresponding to any point, there will be a number. So this statement was given by these two mathematicians, Dedekind and G. Cantor. It's an important point. Please copy this. It has been given in the textbook as well. Let me go for writing the same. Right. Corresponding to every real number, there is a point. On the number line, and corresponding to every point on the number line, corresponding to every point on the number line, there is a real number. Yes. Now, here we are using the word real, that is real numbers. Then what are real numbers? Now, I go for writing some of the numbers, identify and tell what type of numbers are these. Here are right 1, 2, 3, 4 and so on. Immediately you can tell that there are counting numbers called natural numbers, including 0, whole numbers, -2, -3, then 10 and so on. They are all integers. Now I'll write 2 by 3 minus 5 by 7. Now these are rational numbers. Now I go for writing some more. Root 2, root 3, 7 by root 5. All these are irrational numbers. Now see that here we have total collection of rationals and irrationals, and these two are together called real numbers. So real number may be either rational or an irrational. So please copy this. Cited in real numbers. Real numbers. Right. All rationals and irrationals. All rationals and irrationals together called real numbers. Written up. Example. Right. 0, 1, 2, -3, -5, 3 by 7, -2 by 11, 11 by 3, root 2, root 3, -2 by 3, root 7, all these are real numbers. Written up. Now, let us come to know how to represent one of the real number, that is called irrational number, on the number line. So, you can write the side heading representation of irrational number on the number line. Right on side. Representation of irrationals on the number line. Representation of irrationals on the number line. Representation of irrationals on the number line. Now let us come to know how to locate irrationals on the number line. So before that, we need to have some of the basics related to it. Here the irrationals are root 2, root 3, root 5, root 6, root 7 and so on. Now we will come to know how to represent them on the number line. Here just look at the board. I am going to take a square. Please don't copy this. In which all sides are equal. It is a square and one of the properties, all sides are equal. I am going to take AB as 1 unit. What about BC? That will also be 1 unit. If we want to find out AC, the length of AC. How do you find out the length of AC? Can you recall that? Which concept to be used to find out the length of AC? Yeah. Now, when you observe this geometrical figure, ABC is a right triangle. Hence, we can go for using Pythagoras property. According to Pythagoras property, you can write the square on hypotenuse, that is AC square, is equal to the sum of squares of other two sides, AB square plus BC square. And this is equal to, what is AB? 1 unit, 1 whole square. BC, 1 unit, whole square. What is 1 square? Is 1. Again, 1 square is 1. 1 plus 1 is 2. AC square equal to 2. Then what about AC? AC is root 2. Yes. Got it? We got the length of AC. This should be, and length of AC is root 2. It should be represented on the number line. That is this much length. Then simply, general, just observe, it is a number line. I am going to take A and B here. Now, I am going to place this square on this. The same square, ABCD. Now, just we have found out it is the diagonal, it is root 2. Now, can we take this length? Can we mark the length of AC on this number line? Yes, but how you are going to mark? Will you go for taking scale? No need. You can go for using the compasses like this. You go for taking in this way, and when you draw an arc, it ends here, you can mark. So this point will be root 2 on the number line. Got it? Then, so from this activity, we can come to know that to represent the irrational numbers on the number line, geometrical concept is required. That we have come to know. Now, let me go for explaining the actual steps to be followed to represent it on the number line. Now, you can just go for copying again the instruction. Pause the video, copy that, then you can go for play. Now, let us go for taking some examples. Please go on writing with me. Worked examples. Worked examples. In that first one, locate root 2 on the number line. Locate root 2 on the number line. Then ask it geometrically or just this much only, number line. Now please observe this method and don't go for writing this. First, we have to draw a line, and you will go for taking a scale and draw a line. Then the arrow mark on either side. Some will go for drawing like this. Avoid this. Next, mark 0 anywhere else. Here I am taking. From this point, you can go for marking every unit distances. It is better to take 2 centimeter as 1 unit. The distance will be more comfortable for construction. Here I am taking for every 2 centimeter. But here I should take more. Yes. Got it? Unit distances. That distance should be written here in the part called scale. What is that scale? 1 unit is how much? 1 unit is equal to 2 centimeter in your scale. But here I have taken more because it should be visible to you. Now, I'll take this point as 0, this point as 1 and this point as 2. Here on the left side of the 0 or negative, it is negative 1. As I said, you have to place that square on this number line. But how? Observe. I take this point 0 as A, point 1 as B. This is 1 unit. Now, take protractor and draw perpendicular at B. See that. Mark against 90 degree. Then draw the perpendicular at B. This is. Or else you may go for using the set square in this way. Followed? Next, mark it as right angle. Next, observe here, 1, if you want to get to root 2 here, this part should be 1 unit, this should also be 1 unit. Hence, I should mark 1 unit on the perpendicular line. Hence, I go for using the protractor. Sorry, I go for using the compasses. When you are fixing the pencil, please check whether it is correct or not. If it is perpendicular like this, it will be easy for construction. Take the distance of AB. See, here I am taking AB. Got it? With B as center, draw an arc. It cuts the perpendicular at a point. You may call the point as C. What is the distance of BC? This is also 1 unit. Then take a scale and join AC. Then what is the distance of AC? It is root 2. But in construction, you have to, after the construction, you have to show how AC will be root 2. So, you can write like this. In triangle ABC, angle B is 90 degree by Pythagoras theorem or Pythagoras property, AC square is equal to AB square, AC square is equal to AB square plus the perpendicular distance, it is BC square, where AB is 1 unit, BC is also 1 unit, 1 square, it is 2, here right, it is 2. Then we want AC. AC square equal to 2, AC equal to root 2. Now you can write here, it is root 2. But this root 2 should be represented on the number line. Very simple. Take a compasses, then take a distance of AC. Please observe the distance AC. With A as center, draw an arc which cuts the number line at a point. Mark this point. This point is root 2. We know that the value of root 2 is 1.1414. Like this it is continued and it lies between 1 and 2. So root 2 is exactly in between 1 and 2. Understood? Yes. Then you can go for constructing this using the geometrical instrument. Again, my instruction is pause the video, then go for constructing it. Now, we will move on to another one. Let us come to know how to locate root 3 on the number line. This is interesting. Root 3 on the number line. Locate root 3 on the number line. Yes. We have already come to know many irrational numbers. One is already located, and root 3. You can just go for trying this. If not, again I'll go for explaining that in the next class. Got it? So, before concluding the class, my last information is, please do practice the day syllabus on the same day itself. Don't keep anything pending. Got it? And in today's class, we learned some of the important information related to rational numbers, irrational numbers, real numbers, and in addition with that, just about number line. And another important one is locating root 2 on the number line using the geometrical instruments. In the next class, we are going to locate the numbers like root 3, root 5, root 6 on the number line. So with this, let us stop. Thank you very much.